Okay, so for Assalamualaikum and good day everyone. So today we are going to continue with lecture 3, the last lecture for topic 1. So we are going to focus on 1.4, which is the Lagrange multiplier. Okay, so what is the focus on this lecture? First of all, at the end of this lesson, students should be able to formulate the problem related to maximize or minimize z as usual, subject to the constraint of gxy equal to 0. So here we have an additional constraint to the function. And then the second one is to determine the critical points xy by solving the simultaneous equation as usual. And lastly, solve problem related to economics and business as an accounting student, right? Okay, now what is Lagrange multiplier? Okay, Lagrange multiplier. So the method of Lagrange multipliers is a strategy for finding the local maxima and minima of a function subject to equality constraint. So because of this constraint, we need to apply the Lagrange multiplier. Suppose that f of xy and g of xy are differentiable and that f of xy has an extremum subject to the constraint g of xy equal to 0. Then, to find the extreme value, proceed as follows. We have to follow these steps. The first thing is you need to form a new function using the Lagrange multiplier. The new function involving the constraint will be the capital F of xy and lambda. So we have three variables which is equal to f of xy plus lambda gxy. Okay, so this is the new function. And then as usual, we need to find the partial derivative respect to all the three variables. Before this, we only have two variables, right? Because we have the Lagrange multiplier, we need to differentiate partially respect to x, y, and z, and lambda, and all equate to 0. So we have the first equation, second equation, and the third equation here. And the last one is to find the maximum or minimum value. We want to find the value by substituting the point x, y into the function itself. Okay, so lambda is the Lagrange multiplier. So example 1, find the maximum point and value. So point and value of f xy equal to 45 minus x squared minus y squared subject to 2x plus y minus equal to 10. So this is our constraint. Okay, so we have a function with the constraint. So what we need to do is to find a new function. So new function involving lambda, it will be f of xy plus lambda g of xy. But what is our g of xy? It's supposed the function equal to 0, right? So we need to rearrange the 2x plus y equal to 10 to get one-sided as equal to 0. So what we need to do is to bring to the 10 to the left side, we get 2x plus y minus 10 equal to 0. So this is our g of xy. So the new function will be 45 minus x squared minus y squared. And then plus with lambda multiplied by the gxy, which is 2x plus y minus 10. Okay, usually I will ask my student to write down when you expand it. So we get 45 minus x squared minus y squared, and then plus 2x lambda plus y lambda minus 10 lambda. Why? Because directly you can do the differentiation easily lah. Okay, now the second step, we need to find all the partial derivative f sub x. So differentiate f sub x. How to differentiate? So we only consider the variable of x lah. So we have y. Sorry. Kenapa dia tak nak turun? Ink tool ni saja nak main-main ya. Okay, so we have only x. Allah. Okay, so negative x squared. Sorry for the technical error. And then 2x lambda. Okay, so 2x lambda. So differentiate negative x squared, we get negative 2x. But plus 2x lambda, we get 2 lambda. Why? Because lambda also a constant. And then f sub y. So differentiate respect to y, we have negative y squared and y lambda. So negative y squared will be negative 2y, and plus y lambda will be lambda only lah. And the last one is to differentiate respect to lambda partially. Okay, so actually we only have lambda here. So lambda is the variable, so 2x plus y minus 10 here is a constant. So directly you can write down it as 2x plus y minus 10. Right? Or you can choose all the terms with lambda. So we have here 2x lambda plus y lambda minus 10 lambda. So differentiate everything respect to lambda, we get 2x plus y minus 10. Same. Okay? And then after that, what we need to do, we have to equate to 0 every equation this. Okay? After you equate to 0, you can solve simultaneously. But how to solve simultaneously? So we will have 3 equations lah. But for the first equation, we actually can simplify into negative x plus lambda. So, equal to 0 is the first equation. And then the second equation, the third equation. So, the easier way to solve this is to eliminate the lambda first. After we eliminate the lambda, we will have equation in terms of x and y. So, if we can see that here we have lambda, here also we have lambda, we can eliminate the lambda, solve the simultaneous by using the elimination method. So, we can do 1 minus 2 or 2 minus 1, either one lah. It's up to you. So, if we do 1 minus 2, what do we get? We get negative x minus negative 2y. Betul tak? Negative x minus negative 2y will be negative x plus 2y. Right? And then lambda minus lambda will be 0, so equal to 0. So this is the fourth equation. So now we have 3 and 4 equation all in terms of x and y only. Okay, so we can solve the equation in terms of x and y lah. So what do we get? So if we, for the equation number 3, because we have 2x and x here, so it's not the same the coefficient. So y also we have y and 2y. So we can multiply equation number 4 by 2. So if we multiply equation number 4 by 2, we get negative x, negative 2x plus 2y will be positive 4y. So equal to 0. So we have the fifth equation. So solve for 3 and 5 lah. Solve for equation number 3 and equation number 5. So if we solve it, let's say 3 plus 5. Equation number 3 plus equation number 5. So 2x plus negative 2x, we get 0. Right? And then y plus 4y, we get 5y. And then negative 10 plus 0 will be negative 10. So that's why we bring to the right side will be positive 10. So 5y equal to 10 is equal 5y is equal to 10. So y equal to 2. So now can we find the value of x? Yes, we can substitute into either equation 3 or 4. So if we substitute into equation 4, we get negative x plus 2 of y, which is 2. So equal to 0. So x equal to 4. So now we have the point which is 4, 2 lah. X coordinate is 4, y coordinate is 2. And then this is not the final one. We need to find the yes, the maximum value by substituting 4 and 2. So terbalik ni. It's 4 and 2 into the equation. Okay, so the answer will be 25. Apa masalah dia ni? 25 minus kenapa? So the answer will be 25 minus 4 square minus x square and then minus y square, which is 2 square. 35 45 45 so you get what? What is the final answer? Dia tak nak bergerak, minta tolong. 45 minus 4 square minus 2 square will be 25. Okay? Okay. Wow, comotnya. So let's continue with the next slide. Okay, example 2. Hopefully no more technical problem. Okay, so how to minimize f of xy, which is 2x squared plus x plus y squared plus xy, subject to the constraint y equal to 3 minus 2x. Okay. The first thing, as usual, we need to find the new function. But before that, what is the g of xy? Okay, g of xy, rearrange everything. You can either bring the y to the right side or bring the 3 minus 2x to the left side. So we have here, we have g of xy equal to y minus 3 plus 2x. And then the new function will be 2x squared plus x plus y squared plus xy plus lambda of y minus 3 plus 2x. Okay, so we have the new function. We need to find the partial derivative of each of the variable. So for respect to x, we get 2x squared will be, so 2x squared will be for x, and then x will be 1, and then we have xy here, so differentiate xy, y will be constant, so we have y, and then another one, so this here we need to expand on lambda y minus 3 lambda plus 2x lambda. So it will be 2 lambda. Okay, so f sub x. And then f sub y, we get y squared, we get 2y. Mengapakah ini terjadi? So we have 2y, and then differentiate xy, we get x only. And then differentiate lambda y, we get lambda. Dia nak suruh saya conteng kot ni. And then differentiate respect to lambda. So we have lambda y minus 3 lambda plus 2x lambda. So we have y minus 3 plus 2x. Okay, so now we have all of this equation equal to 0. So solve simultaneously. So for the first equation, actually we have 2 lambda. So the second equation, also we need to make the lambda equal to 2 lambda. So we multiply by 2. Everything here multiply by 2. So this is why we have 4y plus 2x plus 2 lambda. And then the third equation, y minus 3 plus 2x equal to 0. So to eliminate the lambda, we can subtract equation 1 to 2. So we have 4x minus 2x, we get 2x. And then y minus 4y will be negative y. And then 1 plus minus 0 will be 1. And then 2 lambda minus 2 lambda. You can see, right? For x minus 2x will be 2x. And then y minus 4y will be negative 3y. And then 1 minus 0 will be 1. And then 2 lambda minus 2 lambda will be 0. Okay. And then we have all of the equation 3 and 4 in terms of x and y. To solve it, we have 2x, 2x here. So directly subtract equation 3 to 4. So y minus negative 3y, we get 4y. And then 2x minus 2x is 0. Negative 3 minus negative 3 minus positive 1 will be negative 4. So 4y minus 4 equal to 0. So we bring 4 to the right side. So 4y equal to 4. So y equal to 1. So if we find out y already, so we can find out for the x. So substitute y into either equation 3 or 4. Apa? 1 or 2? 1 lah kan? 1 into equation 3. So what do we get? We get 1 minus 3 plus 2x equal to 0. So negative 2 plus 2x equal to 0. 2x equal to, so x equal to 1. So we get the answer. The point here is x equal to 1, y equal to 1. So we need to find the x, and then we need to find the value lah. So the minimum point is 1, 1. So the value will be substituting the x equal to 1, y equal to 1 into the f function. So we get 2 of 1 squared plus 1 squared plus 1 multiplied by 1, which is equal to 5. So this is the minimum value. Okay, example 3. So this is the example in the economic and business relation lah. Okay, so let's see the sentence here. So a factory produced two kinds of machine, X and Y. The cost function given C equal to XY, C of XY equal to X squared plus 2Y squared minus XY. If the factory has fixed the total production for both type of machine at 8 units, so X is a number of the first machine and Y is the number of another machines. So if they fix that you need to produce only 8 kinds of machine, betul lah? Produce 8 kind of machine total every day. Okay, let's say every day. So it's either 4 for type A, 4 for type B, or 5 for type A, 3 to type B. How many units of each machine should be used to minimize the cost? Okay, hence find the minimum cost. So this is what we call, we have a constraint. So we have the constraint. Kita ada kekangan. Macam tu. What is the constraint? That we need to produce only 8. Total 8 machine only every day. Let's say that is the constraint. So, what are the solution? What are the constraint? So actually the total machines will be 8, right? So what is the number of machine A? What is the number of machine B? So X will be the machine A, Y will be the number of machine B. So the total will be X plus Y must be equal to 8. So only 8 machine will need to be produced. So this is our constraint. X plus Y equal to 8 is the constraint. Okay, so GXY will be the X plus Y minus 8. Okay, now to find the new function, just combine the cost function with the constraint. So we get X squared plus 2Y squared minus xy plus lambda of X plus Y minus 8. Okay. So solve as usual lah. Kita buat macam example 1 and example 2. So differentiate respect to X. We get 2X minus Y plus lambda. And then differentiate respect to Y. We get 4Y minus X plus lambda. And differentiate respect to lambda. We get X plus Y minus 8. So everything here will be equal to 0. Okay. And then we have the 3 equations. So solve the 3 equations. As I said earlier, we have to eliminate the lambda first. So equation 1 and 2, do something between equation 1 and 2. So we can either subtract 1 subtract equation 2, or 2 subtract equation 1. Either one. So if 1 minus 2, what do we get? 2x minus negative x will be 3x. And then negative y minus 4y will be negative 5y. And then lambda minus lambda is 0, so equal to 0. So this is the 4th equation. So we can solve the 3rd and 4th equation. So because the variable is not the same, the coefficient for each variable is not the same, so we can multiply the equation 3 with, if we want to eliminate x, then we can multiply equation 3 with 3. So we get 3x plus 3y minus 24. So rearrange, we get 3x plus 3y equal to 24. So this is the 4th equation. So solve for equation 4 and 5. So we can do 4 minus 5 ataupun 5 minus 4. So if 5 minus 4, 3x minus 3x is 0. 3y minus negative 5y is 8y. And then 24 minus 0 is 24. So y directly equal to 3. And then we can find out what is the value of x. Substitute into either equation number 3 or equation number 4. So substitute y equal to 3 into equation number 3. We get x plus 3 minus 8 equal to 0. So x equal to 5. So now we have the points already. So we need to produce 5 numbers of product A and 3 numbers of product B to have the minimum cost. So that is our conclusion. So you need to do conclusion for this type of question. Not just directly say that this is the minimum point. No. You have to do the conclusion. Hence, 3 units of machines type 1 and 5 units of machine type 2 should be produced to minimize the cost. So what is the minimum cost? Substitute the value of x and y into the function, the original function. So the cost function we have, so we have 5 squared plus 2 of 3 squared minus 5 of 3, which is the cost will be 28 ringgit. Okay, the cost must be in RM lah. Okay. So last example. An electric company produced hair dryers found that the cost is given by ... where X is the skilled workers and Y is the unskilled workers. So the cost involving the skilled workers and unskilled workers, because we need to pay them, right? So the company will use a total of 100 workers. So the 100 workers might be it's a combination between skilled workers and the unskilled workers, right? X and Y. So determine how many of each kind of worker the company should use to minimize the production cost. Okay, so the same step as example 3. We need to find the constraint function first. So the total workers should be 100. So what is the number of unskilled workers? What is the number of skilled workers? So skilled worker is X, unskilled worker is Y. So X plus Y must be 100. So that's why our constraint function is equal to X plus Y equal to 100. But we need to rearrange so that it equal to 0. So we have X plus Y minus 100 equal to 0. So that will be our constraint function. Now we have the new function, which is f of x y lambda will be 1 over 15 x squared plus 1 over 10 y squared minus 4x minus 4y plus 1000 plus lambda of x plus y minus 100. Okay, so now just do the same step we do in example 1, 2 and 3 to solve for x and y. So what we need to do? Differentiate respect to x and y and lambda partially. So for f sub x we get 2 over 15x and then minus 4 and then plus lambda. And then for f sub y we get 1 over 5y minus 4 plus lambda. And then the last one, f sub lambda is equal to x plus y minus 100. So all these three equations, solve it simultaneously. So it should be involving eliminating the lambda first. So equation 1 minus equation 2. So we have 2 over 15x minus 1 over 5y. Minus 4 minus negative 4 will be minus 4 plus 4, which is 0. So lambda minus lambda is also equal to 0. So this one equal to 0. And then we have the equation 4 lah, which is we can eliminate the denominator by multiplying with by 15. So everything multiply by 15. So that's why we have 2x minus 3y equal to 0. Why this 15 if we bring to the right side will be 0 juga lah. So simple. Daripada you solve the coefficient, fraction in fraction form, but you simplify. So this is the equation number 4. And then solve the equation 3 and 4 together. So we can multiply the equation number 3 with 3. Why? Because we want to multiply the y with 3 to eliminate the y. Okay, so we have 3x plus 3y minus 100, or bring to the right side, minus 300 will be 300 on the right side. So this is equation number 5. So 4 plus 5, equation 4 plus 5, because we have negative 3y and positive 3y. So adding up equation 4 and 5, we get 2x plus 3x will be 5x. Negative 3y plus 3y will be 0, and 0 plus 300 will be 300. So 5x equal to 300, so x equal to 60. So y is equal to, we can also substitute into the constraint, right? So the constraint is, we need to substitute into any of the function xy. So 60 plus y minus 100 is equal to 0. So y is equal to 40. Right? So we have the number of workers. So for x is the skilled workers, we need 60 skilled workers, and y equal to 40. So we need the 40 unskilled workers. So that is the number of workers that we need to use to minimize the cost. Okay, so that's for the last learning outcome for the lecture and the topic. So the Lagrange multiplier. Okay, so I hope you guys understand. It's really simple, just need to consider the constraint. But somehow in the problem question, we need to recognize ourselves. Which one is the function? F of xy. Which one is the constraint? So that will be the typical thing that student will be confusing lah. Okay. So that's all. Thank you.